This is Module 4, Lesson 1. We are going to continue to talk about models of the atom today and lead up to our current model of the atom. So we learned in our last module about Rutherford's gold foil experiment and how Rutherford said that the atom was mostly empty space with a positive dense nucleus in the center of the atom. The problems with Rutherford's model, and I don't really know why this was an issue for the scientific community, but they found fault with it, was that he could not explain why why heated metals or metal compounds would give off color, and that would be like why fireworks explode and give off different colors. Like some give off green, some give off blue, some red. He couldn't explain that. He couldn't explain why heated objects would glow. Like this is a horseshoe that's been heated, and if you continue to heat it, like heat it a little bit, it'll be red like in this area. And then when you heat it more, it starts to be like this yellowish color. And if you heat it enough, it actually gets to be white hot. He couldn't explain the color changes. And he couldn't explain the chemical properties of elements, why certain things will, react with other things, why some things explode when they touch water, etc. So, the scientific community did not think that his model adequately explained the behavior of electrons. So enter Bohr. Bohr, he said that electrons were in specific circular paths or orbits around the nucleus. His model is often referred to as the planetary model because it's like his electrons orbit the nucleus like planets orbit the sun. And so as you can see, like the dates are listed on here. We don't need to know all of these exact little things, but in the early 1900s, Bohr came up with the planetary model and basically said that they travel on these little paths, that kind of like running in a race on a track, like you have to stay in your lane. And he explained a lot about how electrons could gain and lose energy and change back and forth between these energy levels. And so that's what we're going to look at to start with. Is looking at his model. Now, later on, we're going to look at Erwin Schrödinger's model. Schrödinger has the most current model of the atom, which has obviously been a while, almost 100 years. His model of the atom is the electron cloud model, where basically he says that electrons are not in a defined path exactly like Bohr's model, but instead they're kind of in this region of probability, and I'll explain more about that in just a little bit. So, let's talk about Bohr's model some more. According to his model, each atom has fixed energy levels. Those energy levels were the rings. So if you have the nucleus here in the center, the energy levels are these rings that go around it. You might have drawn some of these in middle school. My circles are not that great, so forgive them. Energy levels, according to Bohr, are kind of like rungs on a ladder. And I think about a ladder, like you can step from one rung of the ladder to another. Like if this is a ladder, you can put your feet on this rung or this rung or this rung, but like you can't put your foot right here where my cursor is in between them. If you try, you're just going to fall down to the one below. Electrons work the same way. Like according to him, they cannot be in between. They have to be on one level or the next. Okay, basic principles here that you need to memorize right here through these things. Electrons gain energy to move up the rings, and they lose energy or give it off in order to come back down. I think about the ladder. It requires much more energy of me to climb the ladder than it does to come back down it. So similar for electrons and orbitals. And a quantum of energy is exactly how much it takes for you to move an electron from one energy level to another. Now, let's talk about those energy levels. Here's a picture of Bohr's model. This is giving more information down here at the bottom right here than we need to worry about right this moment. I'm more concerned with the rings up here. The lower energy levels are these that are closest to the nucleus. And as you can tell, they are farther apart. So there's a big distance between energy level 1 and energy level 2. N simply stands for energy level. So anywhere that you see that, like if you see N equals 1, that means energy level 1. N equals 2 means energy level 2. So energy level 1 is a good distance from energy level 2. Then 2 and 3 are closer together. 3 and 4 are even closer together. 4 and 5 are even closer together. 5 and 6 are the closest together. So since the lower levels are further apart, it takes more energy to get from one level to the next. Again, think back to the ladder. It takes a lot more energy to climb steps that are very far apart than close together. Higher energy levels, they're far away from the nucleus. They're closer together, and therefore it takes less energy to get from one level to the next. You need to memorize all of these things about the energy levels too. Chemistry lots of times becomes a big old mess of memorization. Now, looking at Schrodinger's model for just a minute, he came up with the math equation to describe the location of electrons. No worries, we are not going to dive into that mathematical equation. It is well above my head. If you wonder what it is, then you could Google it and get lost really fast. It led to what is called the quantum mechanical model of the atom. Like I said, it's a probability model. It just tells you what your chances are of finding an electron in a given location. And as you can see, like the red is darker in this area, and it gets lighter out here. That means you have a better chance of finding an electron in here, where it's nice and dark, than you do finding an electron out here towards the edges. So your probabilities are just increased. This right here is the cloud. It's the area where the electrons are likely to be found. Now, as we get into this point, basically, we get into some organizational breakdown of the energy levels, okay? So there are three different things that we need to focus on now, and it is orbitals, shapes, and sublevels. So atomic orbitals are these spaces where you have a really good chance of finding an electron. All of this has to do with Schrodinger's quantum mechanical model of the atom. So I think it gets a little bit confusing. There's a lot of pictures to look at, and I'm going to give you some analogies. Just make sure that you don't get lost in the analogy and lose the chemistry. Okay? Here's my rough breakdown for you, okay? The principal energy levels. Principal is often used with these. If that's confusing, then just take out the word principal. Each energy level has a different number of sublevels, and then the sublevel has a different number of orbitals, and the orbitals hold the electrons. So I know that that's a lot right there, but you have the power of video at your hands. You can pause it and go back and listen to it again. So energy levels are made up of sublevels, and sublevels are made up of orbitals, and orbitals, they hold electrons, okay? You're going to have to memorize all these different little pieces so that we can answer questions about them and do things with it, okay? You need to know the different sublevels. The sublevels are S, P, D, and F. I didn't make this up, I'm just the messenger. They're located over here to the right for you. You can see sublevel S right here. It says each sublevel has a different shape and has a different number of orbitals. Well, here's the shapes over here. S it's a sphere, okay? And as you can see, there's only one red circle. So what that means is S only has one orbital. Okay, P has three different shapes. So the P sublevel has three different orbitals. It's roughly dumbbell shape. I think of it kind of like an infinity symbol. If I was drawing it for someone, I would just draw a sideways 8. That's good enough in my mind. There's three versions of those. It has to do with how they're oriented in space. There are three different ones. D. I refer to it kind of like a clover. I mean, it looks kind of like two of the figure 8s for most of these. You can see the 1, 2, 3, 4 little globes on it. The fifth version is kind of wonky looking. You know, it's a little complicated. But there's 5 different versions of the D. So the D sublevel has 5 orbitals. Each one of these different shapes is an orbital. Now the F. The F, I don't even know how to describe it. A lot of books just say that it's quote-unquote complex. There's 7 different versions of it. So the F sublevel has 7 orbitals. Now, how in the world do I remember this? I remember it this way. 1, 3, 5, and 7 goes with S, P, D, and F. S has 1, P has 3, D has 5, and F has 7. So that would be kind of a short little way for you to do this. Now, if you kind of want to look at the whole picture, and yes, you need to know the whole picture. Remember, N is the energy level. So here I've listed for you the energy levels. I've listed for you how many sublevels are in each. For the first little bit, it's a 1 for 1. Like energy level 1 has 1 sublevel. 2 has 2, 3 has 3, 4 has 4. And then we repeat. There's only 4 sublevels, S, P, D, and F. The fifth energy level can't have 5, it only has 4, and then it goes backwards, 4, 3, 2. If we came up with energy level 8, you could predict that it would have 1, so that would be a prediction. Now, how do I remember what they have? Well, y'all, it goes in order. You always start with S, so if you have 1 sublevel, you have no choice but to have S. If you have 2 sublevels, you have S and P. 3, you have SPD. 4, you have SPDF. You must always start with S. If you have something after S, it has to be P, and then D, and then F. Now, as far as the number of electrons, this can kind of be worked out mathematically. On the last one, we had that each orbital could hold 2 electrons. Okay, well remember the S has 1 orbital. 1 orbital can hold 2 electrons. So what about this one? The S has 1 orbital, the P has 3 orbitals. 2 electrons can go in this one. 6 can go in this one because 3 orbitals with 2 electrons each. 3 times 2 is 6. So 2 plus 6 is 8. Okay, what about this one? Well, the S can hold 2. The P can hold 6. What about the D? The D had 5. Remember, S, P, D, 1, 3, 5. The D has 5 orbitals. 5 orbitals times 2 electrons each is 10. Well, 2 plus 6 plus 10 is 18. We can do the same thing with this one, repeating from what we know from before, 2 plus 6 plus 10 plus whatever's in the F. Well, if we go down one more to the F has 7. 1, 3, 5, 7. 7 times 2 is 14. The F sublevel has 7 orbitals, and that can hold a total of 14 electrons. Add all of that up, and you'll get 32. I know that this is a whole lot of information. My advice would be to replay it a couple different times and listen to it. And then think about, like I don't necessarily have this memorized. I just kind of work it out on my own. I know that the S has 1 orbital that can hold 2 electrons. The P has 3 orbitals. Well, that can hold 2 apiece. That's 6. The D has 5. 5 times 2 is 10. I just kind of work it out in my mind. So now, an analogy. All right, here's my loose analogy of this. If we pretend like this rectangle is an apartment building, the apartment building is divided into floors, right? And our floors are divided into different apartments. So the floors for me are going to represent the energy levels. So this would be energy level 1. It's floor 1 of the apartment. Well, remember we said that energy levels are broken down into sublevels. Okay, the sublevels for me are kind of like the apartments. The first energy level in this apartment building, it only has 1 sublevel. It has the S apartment because the sublevels are S, P, D, and F. The orbitals that make up the sublevels for me are kind of like the rooms. So that gives us 4 choices. We can have a 1-bedroom, a 3-bedroom, a 5-bedroom, or a 7-bedroom. So if this is our apartment building and the first level only has the S sublevel, it only has 1 room. So I'm only going to divide it that way. Now, the second floor, the second energy level, it has 2 sublevels. It's got the S and then it's got the P. But remember, the P, somehow I erased everything. The P has, where'd it go? Oh, I switched sides. That's what I did. The P is made up of 3 bedrooms. So, because it has 3 orbitals. So if I switch colors real fast, I would divide it this way. Because the P has 3 orbitals, that's a 3-bedroom apartment. Now the third energy level, well, it's got the S and it's got the P, but it also has the D. We'll divide it in blue this time. So now the S still has 1 bedroom. The P has 3 bedrooms. You can see 1, 2, 3. And the D happens to have 5. 5 bedrooms, mind you. I don't know if I'll get them all in here. So 1, 2, 3, 4, 5. Stay tuned for the rest of this.